Okay, guys, let's review and see if we can't pull out some of these ideas of amplitude and period here with this function, y equals 1/2 sine of 2 pi x. Okay, this value out front is our what? Well, amplitude. The absolute value of A, which would be the absolute value of 1/2. So the absolute value of 1/2 is 1/2. Now remember, our A is going to correspond to vertical stretch or shrink. In this case, our value is between 0 and 1, so it's vertical shrink of 1/2. Okay, now let's do, and that's again our amplitude. Now let's do our period. Well, our period was what? Period equals 2 pi over the absolute value of b. So that would be 2 pi over the absolute value of b, and here my b is 2 pi, whatever's in front of that x. Well, the absolute value of 2 pi is just 2 pi, and 2 pi over 2 pi would be 1. Okay, so we have a period, and that's the length, that horizontal distance it takes to complete one revolution and come back one wave. And remember, amplitude is how far it goes from the midpoint up to its highest or lowest edge, in this case, 1/2. Okay. So by looking at this, I should say, okay, I can identify the amplitude, know whether it's vertical stretch or vertical shrink, in this case, vertical shrink. And then, of course, I could hopefully determine what my period is by doing 2 pi over the absolute value of b. So 2 pi over the absolute value of 2 pi would be just 1. So my period is 1, and my amplitude is 1/2. Okay, so let's go ahead and construct a graph, and I'm going to go ahead and erase so that we can use the space here provided. Okay, and I'll put those values up top when we then go to graph this and construct it, because there's a little bit to the art of constructing a graph like this as well. Or science, if you will. Okay. All right, so again, amplitude A equals 1/2. Our period we determined was 2 pi over 2 pi, which is 1. Okay, so when I go to construct one of these, and maybe before it was a little easier because we just had that set 2 pi period. Here it's going to be a little more interesting because we don't have a period of 2 pi, we've got a period of 1. Okay. Okay, so what I want to do first is I want to plot that period distance here of 1. Okay. And of course I'm starting here at 0, and I'm going to go up to 1. Then I want to break it into 4 parts. Let's divide it in half, and then we'll divide it in half again. Okay, so break period into 4 parts. Well, to find my first location here, I'm going to do my period divided by how much? Well, period divided by 4. When it was just 2 pi, that was 2 pi divided by 4, which became pi halves. But now our period isn't 2 pi, it's 1. Okay, so what's 1 divided by 4? Well, 1/4. So I know I'm at 1/4. Okay, and then now I'm going to add whatever that amount is. Let's say call this value. I'm going to now add that same amount to it to get my next one. Well, a fourth plus a fourth, 1/2. Okay, and then maybe I add another fourth to it, 3/4. And then finally I add one more fourth, and I'm up here to 4/4, which is 1. Okay, so let's think about what we did. We found our period first by doing the 2 pi over b, 2 pi over the absolute value of b, which gave me 1. Then I wanted to first plot that, so then I plotted this 1, but I gave myself room here to break it into 4 parts. And then I broke my period into 4 parts by doing my period divided by 4. So period was 1 in this case. 1 divided by 4 was a fourth. Then I added whatever that value was to that value, and then I kept adding that same amount until I got to all my locations. Okay, let me erase in part. Okay, so I'm going to leave my locations there. Okay, and I'm going to give myself a little room to work here. So notice, we have to find the amplitude and the period, but then we have to take that period length, plot it first, and then divide it in 4 parts. And then, of course, I'm going to add whatever that period length is here to 0, and then I'm going to add whatever that period length is to the period length each time, and then I'll construct all my locations. Okay. And maybe this. Okay, say then we wanted to say like use a table to evaluate points because we still weren't sure. Okay, so let's go ahead and make an XY table. Well, let's evaluate those locations. 1/4, 1/2, 3/4, and 1. Well, here's where knowing the unit circle is going to save me a lot of time. Let's evaluate, say, 1/4 first. 1/2 sine of 2 pi times 1/4. Notice 1/4 here went in for x. Okay. Plug in for x, solve for y. Same thing. Okay, so here's 1/4. Well, what's 1/4 times 2 pi? Well, that would be pi over 2. Well, what's the value of sine of pi over 2? Well, pi over 2 was a 90, so I know sine at that location should be positive 1. And then don't forget I have to multiply by the half out front, and that's a half. Okay, let's evaluate another point. Y equals 1/2 sine of 2 pi times a half. Well, 2 pi times a half, I want to multiply these two first, and that should just be pi. So the sine of pi, 1/2 the sine of pi. Well, what's the sine of pi? Well, I think pi on the unit circle, that'll be 0, because I'll be 0 on the y-axis at pi. So knowing that unit circle is saving me a lot of time here. 0 times a half equals 0. 0. Then, let's keep going. We'd evaluate the other points. Let me erase. Okay. So let's evaluate the last couple. Y equals 1/2 sine of 2 pi times 3/4. Well, that would become 6 pi fourths, which is 3 pi. Okay, so let's finish. Again, so we evaluated sine of 3 pi halves. I knew where I was in the unit circle. That's a 0 on x, -1 on y, and we just want the y value for sine. That's -1. -1 times a half, -1/2. Okay, and I plotted all these points. And I graphed them. I essentially graph one period worth, one wavelength. One wave came, one revolution came back to where it started. Notice it went up as high as the amplitude, 1/2. Came down, went down as low as the amplitude, 1/2. In this case, the absolute value of the amplitude. And then it came back up here to 1. Okay, remember our period was 1. We divided 1 into 4 parts. And then we evaluated our points as we went, and we were able to graph one period of it.